Xhtml. Extensible HyperText Markup Language Xhtml is part of the family of XML markup languages. It mirrors or extends versions of the widely used Hypertext Markup Language HTML, the language in which web pages are formulated. While HTML, prior to HTML5, Xhtml documents are well-formed and may therefore be parsed using standard XML parsers, unlike HTML, which requires a lenient HTML-specific parser. Xhtml 1.0 became a World Wide Web Consortium W3C recommendation on January 26, 2000. Xhtml 1.1 became a W3C recommendation on May 31, 2001. The standard known as Xhtml5 is being developed as an XML adaptation of the HTML5 specification. Overview. Xhtml 1.0 is a reformulation of the three HTML4 document types as applications of XML 1.0. The World Wide Web Consortium W3C also continues to maintain the HTML 4.1 recommendation, and the specifications for HTML5 and Xhtml5 are being actively developed. In the current Xhtml 1.0 recommendation document, as published and revised to August 2002, the W3C commented that the Xhtml family is the next step in the evolution of the Internet. By migrating to Xhtml today, content developers can enter the XML world with all of its attendant. The WATOG eventually began working on a standard that supported both XML and non-XML serializations, HTML5, in parallel to W3C standards such as Xhtml2. In 2007, the W3C's HTML working group voted to officially recognize HTML5 and work on it as the next generation HTML standard. In 2009, the W3C allowed the Xhtml2 working group's charter to expire, acknowledging that HTML5 would be the sole next-generation HTML standard, including both XML and non-XML serializations. Of the two serializations, the W3C suggests that most authors use the HTML syntax rather than the Xhtml syntax. Motivation. Xhtml was developed to make HTML more extensible and increase interoperability with other data formats. In addition, browsers were forgiving of errors in HTML, and most websites were displayed despite technical errors in the markup. Xhtml introduced stricter error handling. HTML4 was ostensibly an application of Standard Generalized Markup Language (SGML). However, the specification for SGML was complex, and neither web browsers nor the HTML4 recommendation were fully conformant to it. The XML standard, approved in 1998, provided a simpler data format closer in simplicity to HTML4. By shifting to an XML format, it was hoped HTML would become compatible with common XML tools, servers, and proxies would be able to transform content as necessary for constrained devices such as mobile phones. By using namespaces, XHTML documents could provide extensibility by including fragments from other XML-based languages, such as scalable vector graphics and MathML. Finally, the renewed work would provide an opportunity to divide HTML into reusable components, XHTML modularization, and clean up untidy parts of the language. Relationship to HTML. There are various differences between XHTML and HTML. The document object model DOM is a tree structure that represents the page internally in applications, and XHTML and HTML are two different ways of representing that in markup. Both are less expressive than the DOM, for example, may be placed in comments in the DOM, but cannot be represented in a comment in either XHTML or HTML, and generally XHTML's XML syntax is more expressive than HTML. For example, arbitrary namespaces are not allowed in HTML. XHTML uses an XML syntax, while HTML uses a pseudo-SGML syntax, officially SGML, for HTML4 and under, but never in practice, and standardized away from SGML in HTML5. Because the expressible contents of the DOM in syntax are slightly different, there are some changes in actual behavior between the two models. Syntax differences, however, can be overcome by implementing alternate translational framework within the markup. First, there are some differences in syntax. Broadly, the XML rules require that all elements be closed, either by a separate closing tag or using self-closing syntax, e.g., while HTML syntax permits some elements to be unclosed because either they are always empty, e.g., or their end can be determined implicitly, omissibility, e.g. XML is case sensitive for element and attribute names, while HTML is not. Some shorthand features in HTML are omitted in XML, such as one attribute minimization, where attribute values or their quotes may be omitted, e.g., or option selected equals selected, while in XML this must be expressed as two-element minimization may be used to remove elements entirely, such as inferred in a table if not given, and there are numerous other technical requirements surrounding namespaces and precise parsing of white space and certain characters and elements. The exact parsing of HTML in practice has been undefined until recently. See the HTML5 specification HTML5 for full details, or the working summary HTML vs. Xhtml. In addition to the syntactical differences, there are some behavioral differences, mostly arising from the underlying differences in serialization. For example, behavior on parse errors differ. A fatal parse error in XML, such as an incorrect tag structure, causes document processing to be aborted. Most content requiring namespaces will not work in HTML, except the built-in support for SVG and MathML in the HTML5 parser, along with certain magic prefixes such as xlink. JavaScript processing is different in XHTML, with minor changes in case sensitivity to some functions, and further precautions to restrict processing to well-formed content. Scripts must not use the document write method. It is not available for XHTML. The inner HTML property is available, but will not insert non-well-formed content. On the other hand, it can be used to insert well-formed namespaced content into XHTML. Cascading style sheets CSS are also applied differently. Due to XHTML's case sensitivity, all CSS selectors become case sensitive for XHTML documents. Some CSS properties, such as backgrounds, set on the element in HTML are inherited upwards into the element. This appears not to be the case for XHTML. Adoption. Criticism. In the early 2000s, some web developers began to question why web authors ever made the leap into authoring in XHTML. Others countered that the problems ascribed to the use of XHTML could mostly be attributed to two main sources: the production of invalid XHTML documents by some web authors and the lack of support for XHTML built into Internet Explorer 6. They went on to describe the benefits of XML-based web documents, i.e., XHTML, regarding searching, indexing, and parsing, as well as future-proofing the web itself. In October 2006, HTML inventor and W3C chair Tim Berners-Lee, introducing a major W3C effort to develop a new HTML specification, posted in his blog that the attempt to get the world to switch to XML all at once didn't work. The large HTML generating public did not move. The current HTML5 working draft says special attention has been given to defining clear conformance criteria for user agents in an effort to improve interoperability, while at the same time updating the HTML specifications to address issues raised in the past few years. Ian Hickson, editor of the HTML5 specification, criticizing the improper use of XHTML in 2002, is a member of the group developing this specification and is listed as one of the co-editors of the current working draft. Simon Pieters researched the XML compliance of mobile browsers and concluded the claim that XHTML would be needed for mobile devices is simply a myth. Versions of XHTML. XHTML 1.0. December 1998 saw the publication of a W3C working draft entitled Reformulating HTML and XML. This introduced Voyager, the codename for a new markup language based on HTML4, but adhering to the stricter syntax rules of XML. By February 1999, the name of the specification had changed to XHTML 1.0, the Extensible HyperText Markup Language, and in January 2000 it was officially adopted as a W3C recommendation. There are 3 formal DTD for XHTML 1.0, corresponding to the 3 different versions of HTML 4.1. XHTML 1.0 strict is the XML equivalent to strict HTML 4.1 and includes elements and attributes that have not been marked deprecated in the HTML 4.1 specification. As of November 2015, XHTML 1.0 strict is the document type used for the homepage of the website of the World Wide Web Consortium. XHTML 1.0 transitional is the XML equivalent of HTML 4.1 transitional and includes the presentational elements such as center, font, and strike excluded from the strict version. XHTML 1.0 frameset is the XML equivalent of HTML 4.1 frameset and allows for the definition of frameset documents, a common web feature in the late 1990s. The second edition of XHTML 1.0 became a W3C recommendation in August 2002. Modularization of XHTML. Modularization provides an abstract collection of components through which XHTML can be subsetted and extended. The feature is intended to help XHTML extend its reach onto emerging platforms such as mobile devices and web-enabled televisions. The initial draft of modularization of XHTML became available in April 1999 and reached recommendation status in April 2001. The first modular XHTML variants were XHTML 1.1 and Xhtml Basic 1.0. In October 2008, modularization of XHTML was superseded by Xhtml Modularization 1.1, which adds an XML schema implementation. It was itself superseded by a second edition in July 2010. Xhtml 1.1 Module-based XHTML. Xhtml 1.1 evolved out of the work surrounding the initial modularization of Xhtml specification. The W3C released a first draft in September 1999. Recommendation status was reached in May 2001. The modules combined within Xhtml 1.1 effectively recreate Xhtml 1.0 strict, with the addition of Ruby annotation elements Ruby, RBC, RTC, RB, RT, and RP to better support East Asian languages. Other changes include removal of the name attribute from the nmap elements, and in the first edition of the language, removal of the lang attribute in favor of XML, lang. Although XHTML 1.1 is largely compatible with XHTML 1.0 and HTML4, in August 2002, the working group issued a formal note advising that it should not be transmitted with the HTML media type. With limited browser support for the alternate application /XHTML plus XML media type, XHTML 1.1 proved unable to gain widespread use. In January 2009, a second edition of the document XHTML Media Types second edition was issued, relaxing this restriction and allowing XHTML 1.1 to be served as text/HTML. A second edition of XHTML 1.1 was issued on 23 November 2010, which addresses various errata and adds an XML schema implementation not included in the original specification. It was first released briefly on 7 May 2009 as a proposed edited recommendation before being rescinded on 19 May due to unresolved issues. Xhtml Basic. Since information appliances may lack the system resources to implement all Xhtml abstract modules, the W3C defined a feature-limited Xhtml specification called Xhtml Basic. It provides a minimal feature subset sufficient for the most common content authoring. The specification became a W3C recommendation in December 2000. Of all the versions of Xhtml, Xhtml Basic 1.0 provides the fewest features. With Xhtml 1.1, it is one of the two first implementations of modular Xhtml. In addition to the core modules structure, text, hypertext, and list, it implements the following abstract modules: basic forms, basic tables, image, link, meta-information, object, style sheet, and target. Xhtml Basic 1.1 replaces the basic forms module with the forms module and adds the intrinsic events presentation and scripting modules. It also supports additional tags and attributes from other modules. This version became a W3C recommendation on 29 July 2008. The current version of Xhtml Basic is 1.1 Second Edition 23 November 2010, in which the language is re-implemented in the W3C's XML schema language. This version also supports the lang attribute. Xhtml Print. Xhtml Print, which became a W3C recommendation in September 2006, is a specialized version of Xhtml Basic designed for documents printed from information appliances to low-end printers. Xhtml Mobile Profile. Xhtml Mobile Profile, abbreviated Xhtml MP or Xhtml MP, is a third-party variant of the W3C's Xhtml Basic specification. Like Xhtml Basic, Xhtml was developed for information appliances with limited system resources. In October 2001, a limited company called the Wireless Application Protocol Forum began adapting Xhtml Basic for WAP 2.0, the second major version of the Wireless Application Protocol. WAP Forum based their DTD on the W3C's modularization of Xhtml, incorporating the same modules the W3C used in Xhtml Basic 1.0 except for the target module. Starting with this foundation, the WAP Forum replaced the Basic Forms module with a partial implementation of the Forms module, added partial support for the legacy and presentation modules, and added full support for the style attribute module. In 2002, the WAP Forum was subsumed into the Open Mobile Alliance OMA, which continued to develop Xhtml Mobile Profile as a component of their OMA browsing specification. Xhtml Mobile Profile 1.1. To this version, finalized in 2004, the OMA added partial support for the scripting module and partial support for intrinsic events. Xhtml MP 1.1 is part of v2.1 of the OMA browsing specification 1 November 2002. Xhtml Mobile Profile 1.2. This version, finalized 27 February 2007, expands the capabilities of Xhtml MP 1.1 with full support for the Forms module and OMA text input modes. Xhtml MP 1.2 is part of v2.3 of the OMA browsing specification 13 March 2007. Xhtml Mobile Profile 1.3. Xhtml MP 1.3 finalized on 23 September 2008 uses the Xhtml Basic 1.1 document type definition, which includes the target module. Events in this version of the specification are updated to DOM Level 3 specifications, i.e., they are platform and language neutral. Xhtml 1.2. The Xhtml2 working group considered the creation of a new language based on Xhtml 1.1. If Xhtml 1.2 was created, It would include WAI area and role attributes to better support accessible web applications, and improved semantic web support through RDFA. The input mode attribute from Xhtml Basic 1.1, along with the target attribute for specifying frame targets, might also be present. The Xhtml2WG had not been chartered to carry out the development of Xhtml since the W3C announced that it does not intend to recharter the Xhtml2WG and closed the WG in December 2010. This means that Xhtml 1.2 proposal would not eventuate. Xhtml 2.0. Between August 2002 and July 2006, the W3C released 8 working drafts of Xhtml 2.0, a new version of Xhtml able to make a clean break from the past by discarding the requirement of backward compatibility. This lack of compatibility with Xhtml1, X and HTML4 caused some early controversy in the web developer community. Some parts of the language, such as the role and RDFA attributes, were subsequently split out of the specification and worked on as separate modules, partially to help make the transition from Xhtml1 X to Xhtml 2.0 smoother. A 9th draft of Xhtml 2.0 was expected to appear in 2009. But on July 2, 2009, the W3C decided to let the Xhtml2 working group charter expire by that year's end, effectively halting any further development of the draft into a standard. Instead, Xhtml 2.0 and its related documents were released as W3C notes in 2010. New features to have been introduced by Xhtml 2.0 included: HTML forms were to be replaced by Xforms, an XML-based user input specification allowing forms to be displayed appropriately for different rendering devices. HTML frames were to be replaced by Xframes. The DOM events were to be replaced by XML events, which uses the XML document object model. A new list element type, the NL element type, were to be included to specifically designate a list as a navigation list. This would have been useful in creating nested menus, which are currently created by a wide variety of means, like nested unordered lists or nested definition lists. Any element was to be able to act as a hyperlink, e.g., articles, similar to Xlink. However, Xlink itself is not compatible with Xhtml due to design differences. Any element was to be able to reference alternative media with the src attribute, e.g., a London Bridge is the same as London Bridge. The alt attribute of the img element was removed. Alternative text was to be given in the content of the img element, much like the object element, e.g., HMS Audacious. A single heading element H was added. The level of these headings was determined by the depth of the nesting. This would have allowed the use of headings to be infinite, rather than limiting use to 6 levels deep. The remaining presentational elements I, B, and TT, still allowed in Xhtml1, X even strict, were to be absent from Xhtml 2.0. The only somewhat presentational elements remaining were to be sup and sub for superscript and subscript respectively, because they have significant non-presentational uses and are required by certain languages. All other tags were meant to be semantic instead, e.g. strong for strong emphasis, while allowing the user agent to control the presentation of elements via CSS, e.g. rendered as boldface text in most visual browsers, but possibly rendered with changes of tone in a text-to-speech reader, larger plus italic font per rules in a user and style sheet, etc. The addition of RDF triple with the property and about attributes to facilitate the conversion from Xhtml to RDF/XML. Xhtml5. HTML5 grew independently of the W3C through a loose group of browser manufacturers and other interested parties calling themselves the WHATG, or Web Hypertext Application Technology Working Group. The key motive of the group was to create a platform for dynamic web applications. They considered XHTML 2.0 to be too document-centric and not suitable for the creation of Internet forum sites or online shops. HTML5 has both a regular text/HTML serialization and an XML serialization, which is also known as XHTML5. The language is more compatible with HTML4 and XHTML1X than XHTML 2.0 due to the decision to keep the existing HTML form elements and events model. It has many new elements not found in XHTML1X, however, such as section and aside tags. The XHTML5 language, like HTML5, uses a doctype declaration without a DTD. Furthermore, the specification deprecates earlier XHTML DTD by asking the browsers to replace them with one containing only entity definitions for named characters during parsing. Semantic content in XHTML. XHTML plus RDFA is an extended version of the XHTML markup language for supporting RDF through a collection of attributes and processing rules in the form of well-formed XML docu. This host language is one of the techniques used to develop semantic web content by embedding rich semantic markup. Valid XHTML documents. An XHTML document that conforms to an XHTML specification is said to be valid. Validity assures consistency in document code, which in turn eases processing, but does not necessarily ensure consistent rendering by browsers. A document can be checked for validity with the W3C markup validation service for XHTML5. The validator, New Living Validator, should be used instead. In practice, many web development programs provide code validation based on the W3C standards. Root element. The root element of an XHTML document must be HTML and must contain an XMLNS attribute to associate it with the XHTML namespace. The namespace URI for XHTML is http://www.w3.org/1999/XHTML. The example tag below additionally features an XML lang attribute to identify the document with a natural language. Doctypes. Doctypes. In order to validate an XHTML document, a document type declaration or doctype may be used. A doctype declares to the browser the document type definition DTD to which the document conforms. A document type declaration should be placed before the root element, the system identifier part of the doctype, which in these examples is the URL that begins with http:// need only point to a copy of the DTD to use. If the validator cannot locate one based on the public identifier, the other quoted string, it does not need to be the specific URL that is in these examples. In fact, authors are encouraged to use local copies of the DTD files when possible. The public identifier, however, must be character for character, the same as in the examples. XML declaration. Backward compatibility. Examples. The following are examples of XHTML 1.0 strict, with both having the same visual output. The former one follows the HTML compatibility guidelines of the XHTML media types note, while the latter one breaks backward compatibility, but provides cleaner markup. Example 1. Example 2. Notes. The load function is actually a workaround for Internet Explorer. It can be replaced by adding within. The img element does not get a name attribute in the XHTML use ID instead. Cross-compatibility of XHTML and HTML. HTML5 and XHTML5 serializations are largely intercompatible if adhering to the stricter XHTML5 syntax, but there are some cases in which XHTML will not work as valid HTML5, e.g., processing instructions are deprecated in HTML, are treated as comments and close online